Problems on t distribution. In that first, find t 0.025 when nu equals to 14, b minus t 0.01 when nu equals to 10, and c t 0.995 when nu equals to 7. Hello everyone. In the last lecture, we have discussed the concept of t distribution. In this lecture, we are going to find some problems on that concept. So to solve these three problems, we are using t distribution table, that is statistical t distribution table. The first problem is t 0.025 when nu equals to 14. Nu means here degrees of freedom. So in t distribution table, we look at the nu 14th row. So you all know this is a t distribution table. Here we look at the row nu equals to 14. Nu equals to 14. So observe this t distribution table here. Here this is a t distribution table. These are all the body of t distribution. The first column indicates the degrees of freedom. These are all alpha values, means probabilities. These are all t alpha values. Look at alpha equals to 0.25 on the row 14th is 2.145. This is the value corresponding to nu equals to 14 and alpha equals to 0.025 is 2.145. And the second problem is minus t 0.01 when nu equals to 10. So on the same table we have use nu equals to 10. Here 10th row, at 0.01 column alpha here. Yes. So 10th row 0.01 column, the value corresponding these two is 2.764. Okay. 10th degrees of freedom 10 and alpha 0.01 is minus 2.764. And the C problem is t 0.995 when nu equals to 7. Look at the t distribution table for this value. But here alpha is, suffix value is alpha, we know. Alpha is 0.995. It is greater than 0.5. So in this case we have the formula in a t distribution. That is, if alpha greater than 0.5, then we have the formula t1 minus alpha equals to minus t alpha. So our value t 0.995 can be written in the form of t1 minus alpha form. That is, this is 0.995 will always equals to 1 minus 0.005. Okay, so it is also equals to minus t alpha. So minus t, here alpha place is 0.005. So we need to find minus t 0.005 at degrees of freedom 7. Look at this table here at the degrees of freedom 7 at 0.005. At 0.005, the corresponding value is 3.499. So here minus symbol is also there, minus 3.499. This is the problem. Now the second problem is a random sample of size 25 from a normal population has the mean mean x bar equals to 47.5 and the standard deviation small s is equals to 8.4. Does this information tend to support for refuse the claim that the mean of the population is mu equals to 42.1? This is the claim. So for refuse the claim. Solution. From the given problem we have the data. Sample of size means n equals to 25 and x bar equals to 47.5. Here standard deviation s is equals to 8.4 and mu is also given lastly here 42.1. To test this information, we need to depend upon a t distribution. We have the t value as x bar minus mu by s by root n. So substitute the required values here, 47.5 minus 42.1 by s value is here 8.4 by root n value is 25. So by simplify we have the value 2.21. This is the t value, that is t equals to 3.21. It is the calculated value by using this formula. With degrees of freedom, so what is degrees of freedom formula? Nu equals to, we know, n minus 1. Here n value is 25, minus 1 is 24. Now we need to calculate tabular value for the degrees of freedom 24. For degrees of freedom 24, which is near to the calculated value. So look at the t distribution table here. 24 on the 24th row, we have the last value is 2.797. So that information will be written like this. We get the probability that t will exceed, so t values exceed 2.797. The last value is 2.797 in this table. Okay. In this table we have 24th row, the last value is 2.797 of alpha is 0.005 at the area. Alpha is 0.005. So this is tabular value at alpha 0.005 at degrees of freedom 24. So from this is the tabular value. It is denoted by T alpha, that is 2.799. So this is a tabular calculated value and this is a tabular value. From this information we have the t is the calculated value, that is equals to 3.21, and tabular value of t means table value of t is denoted by T alpha, that is 2.799. So observe these two, we have t is always greater than T alpha. Therefore, we conclude that what we need to show here, support for refuse the claim. Since the calculated value t is greater than tabular value T alpha, we reject the claim, that is refuse the claim that mean of the population